Cartesian product or cross product of two sets A and B. Cartesian product is denoted as A cross B, which is set of all ordered pairs x comma y for every x belong to set A and for every y that belong to set B. Let's try to write its roster form. 1 1 1 2 1 3 1 4 1 5 1 6 1 7 1 8 2 1 2 2 2 3 2 4 2 5 2 6 2 7 2 8 3 1 3 2 3 3 up to 3 8 4 1 4 2 to 4 8 5 1 5 2 etc. till 5 8. All possible pairs formed with first element taken from set A and second element taken from set B is called A cross B or Cartesian product of set A and set B. Here, set A and set B have 5 and 8 elements respectively. Hence, A cross B has 5 into 8, 40 elements. Let's consider another set. Set of pairs x comma y such that the second element y should be x plus 2, the first element plus 2. For every x that belong to same set A and set y belong to set B. Let's see which all pairs will belong to this set. We'll try to write it in the roster form. That means writing the individual ordered pairs satisfying this particular condition. X represent an element of the first set. Y represent an element of the second set. Here, the second element y should be x plus 2, the first element plus 2. So the pair 1, 3 will belong to this set because 3 is 1 plus 2. 2, 4, 3, 5 because 5 is equal to 3 plus 2. 4, 6 since 6 is equal to 4 plus 2. 5, 7. These are the only pairs that will belong to this set. And also notice that these many elements are elements of A cross B also. Hence, this new set is a subset of A cross B. Any subset of A cross B is called a relation from set A to set B. Relation from set A to set B, where set A and set B are non-empty sets. Then, a relation from A to B is simply any subset of A cross B, denoted as R1 defined from set A to set B. Now, all the elements whose images are calculated, the elements of the first set involved in the subset, involved in the relation, this called domain of the relation, and all the elements of the set B which are involved in the ordered pairing, this set is called range. So, set domain is set 1, 2, 3, 4, 5. Range of this relation is set 3, 4, 5, 6, 7. And the second set B is called codomain also. Let's see another example. This time, the set builder form says set should be of all ordered pairs in such a way that the second element y should be square of the first element x. Y is equal to x square for every x belong to set A and for every y that belong to set B. Let's see what all ordered pairs will belong to this given set. Of course, 1, 1 since 1 is square of 1 itself. 2, 4 also belong to this relation because 4 is the square of 2. Now, 3 cannot have an image because 3 square is 9. 3 can be related only to 9 which is not available in set B. So these are the only two ordered pairs belonging to this given set. Even this is a subset of A cross B. Hence, even this subset is a relation from set A to set B. Let's call it set R2, relation R2. Domain of this relation is only set 1, 2 because these are the only elements which have some image under this relation. And range of this set, range of this relation is set 1, 4. No other elements belong to the range because none of them is an image of any element of the domain. But the codomain is the whole of set B, 1 to 8. Let's go for another example. This time, the subset has to be created by the condition that x, y pair where y is divisible by x. And here we go. Roster form. 1 is related to all these elements as 1 is divisible by 1, 2 is divisible by 1, 3 is divisible by 1, 4 is divisible by 1. All of these elements of set B are divisible by 1. Now 2 can have very limited images. 2, 2, 2, 4, 2, 6, 2, 8. 2, 8 because 8 is divisible by 2. 2, 6 because 6 is divisible by 2, etc. And 3, and 3, 6 are the only pairs involving number 3 as x. 4, 4, 8. And 5, 5. 5 has only one image, 5, 5. No other element will satisfy the given condition. And here again we got another subset of the A cross B. So this is another relation because even this R3, this new set of ordered pairs is a subset of A cross B. Hence even this is a relation from A to B. Here domain is complete set A 1, 2, 3, 4, 5. Range is also complete set B. All elements have become the images. Codomain is obviously the complete set B. How many relations are possible from set A to set B if set A has m elements and set B has n elements? Here we notice A cross B, the Cartesian product of A and B, is set of all possible pairs x, y, where x belong to set A and y belong to set B. Therefore, A cross B will consist of m into n elements. Each element of set A, each element of the m elements of set A is associated with, made pair with every element of set B. So mn ordered pairs are possible. Now, any relation from set A to set B is a subset of A cross B. Since A cross B has mn elements, they can be 2 raised to the power mn subsets. Each subset of A cross B is called a relation from set A to set B. So, number of relations from set A to set B is 2 raised to the power mn relations. So, if set A has m elements, set B has n elements, there are mn elements in the A cross B, and therefore they can be 2 raised to the power mn subsets for A cross B. Each subset is a relation from A to B, hence 2 raised to the power mn relations are possible from set A to set B. Thank you.